Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the thioglycoside and its different derivatives, and there are some of the beautiful scheme we have discussed, how we are getting as a different type of the derivatives starting from as a thioglycosides. So using as a thioglycoside, how it can act as an donor, and we are getting as a glycosyl halide like as a bromide, fluoride, chloride, or we can get as a trichloroacetamate also, or we can get as a sulfoxide type of the derivative with the help of different oxidizing reagent, specifically as a metachloroperbenzoic acid. So that kind of the thing we have discussed yesterday. Today what we are going to discuss, let us see over here. Thioglycoside as an acceptor. Whatever we have discussed so far, that thioglycoside act as an donor, that type of the concept we have learned. Now is a acceptor, what, when it can, in what condition it can act as an acceptor. So that is the thing which we are discussing by taking one or two scheme of the example. By knowing that, we will discuss some of the scheme which can help us for understanding the concept of glycoside as an acceptor. Most other donor can effectively be used in coupling to thioglycoside acceptor to give thioglycosaccharides blocks. For example, halides donor using halide assisted conditions, or heavy metal salt promoters, trichloroacetamidates donor with hard Lewis acid promoter, selenoglycinide with AgOTF activation, and sulfoxide donor with TMSOTF or trifluoric anhydride as a promoter. And the efficiency in the coupling are dependent on the reactivity of the acceptor and donor, and complication can be arise especially with activated thioglycoside acceptor when transglycosylation of the thiol is an often observed side reaction, and which is shown in the scheme number 8 over here. Let's see here how that can be act as an acceptor. So let's see one of the scheme over here. See over here, that is a scheme I have drawn one of the structure, that is Br at axial position, mean that beta alpha position above, because this one is alpha position. I have drawn that structure is oppositely OAC. Then here you can write OAC at this position also OAC, and here you can just remember as a also as a OC. But this is a what we can call it. It is act as an donor here. It is act as an donor, and what is that? This is a glycoside bromide. This is a glycoside bromide, and as we know that it is act as an donor. Now here it is opposite to that, and then when it is treated with this is the structure which I am going to represent over here is this one. Once again, here is a structure I am shown over here. Let's see, and here is a thioglycol, so which is present at equatorial position, ET, thioglycol, and here it is this one get protected this, and now here is a protection, and that I am showing representing with a flying wedge formula structure over there, that is a tetrahedral carbon atom shown over here, and others. So here is a hydroxy group which is a free, so that O alkylase, O glycoside, thioglycoside can be formed over here. Let's see how, what are, this is known as a thioglycoside. This is act as an acceptor over here, acceptor, and what is this? The name of this compound is a thioglycoside, is a thioglycoside. This is the name of this compound, thioglycoside, and when it is treated with the reagent, like first reagent we added over here Hg, that is mercury, Hg and Cn twice, or we can use HgBr2, the reagent in presence of, that is AgOTF, used as an promoter here, and or we can use as a solvent here CH2Cl2, that is a dichloromethane, or we can use as a diethyl ether, Et twice O, or we can use as a toluene over here, toluene. These are the different reagents we can use here, or you can try to find out the yield which solvent will give the better yield, that you can check here. But the yield what they have got, that one act as an acceptor and one act as an donor over here, and they got the compound generally thioglycoside toluene, and if they carry out the same reaction what they got over here, they got as a thioglycoside only. This goes in the above position, and rest of the thing is remains here. The unexpected, the product which they have got is this one. No, yeah, not like this. So let me draw properly over here. The structure is either this chair form, and now here is a SET, then the OAC acetyl group, here OAC, here also OAC acetyl group. So this type of the derivatives, then further they can attack with that, and the product which they got, that is a 60 to 80%, that is the yield obtained from this reaction. So look at here, thioglycoside act as an acceptor, how it can act as an acceptor, and we are getting as this type of the derivative here, or the product formation. So this is all about the how the main point of discussion over here. What you have to remember here, how this thioglycoside act as an acceptor, and we are getting as this type of the product. That's it. And now taking the knowledge of protecting group influence on the reactivity into account, it is normally possible to design an efficient way to thioglycosaccharide block. However, the protection group manipulation might be tedious and surprises might be encountered. That is the scheme number 29 is shown over here, and that is the scheme we are going to represent here. Let us see how we can represent that compound. Let's see over here. So what is that? One can act as this scheme. So let us see thioglycoside act as an acceptor. That is a second example we are talking over here. So let us see that structure. This second example. Then here let's see, here is a Br halide group over here, and then here must be OAC, and I think here is a one more chlorine group, and then here is a group TBMSO, TBDMSO. That is the compound which we are learning here. TBDMSO. Now at equatorial position there is a what we can call it as a oxygen atom, and at this position also as a oxygen atom, and then here is a pH we can show over here. And now this is as we know that this structure is nothing but as a glycoside bromide, and it is act as an donor, as we know that, and with this we can use as a thioglycoside, and which can act as an acceptor, right? Which can act as an acceptor over here. So how we can represent this? Let's see over here. This is a structure I have drawn here. Let's see, this is at equatorial position ET, and now then OBZ over here, OBZ benzyl group, here BZ, and here also as a OBZ, here also OBN. This is a benzyl group, and this is a benzoyl group. Remember, BN stand for benzyl group, pH, then CH2Cl. So this part we can call it BNCl, benzyl group. And now for BZ, the abbreviation BZ is nothing but, BZ means pH C double bond O Cl, benzoyl. This we can write as a BZ group, right? So that is the thing which we are discussing over here. So that are the product which we are learning here, and now it can be acted as an acceptor, right? This is a donor, this is a acceptor, and after that when we are adding over here, that is a AgOTF, and now 90% yield we are getting here. It is a 90% yield, and how sorry, here is a hydroxyl group. I forgot to write that one, but it is a actual the hydroxyl group deprotected selectively, so that the coupling of these two compounds takes place and the resulting compound will be obtained. This and this get reacted together. What we here again look at here, the reaction when they couple together, this is act as an acceptor, this is act as an donor. So now this nucleophile can be attacking from backside, that is a SN2 type of the reaction, and we are going to get the product like this. Here O, we can write this O over here, and the rest of the thing we can show over here. This one, there is a pH, another one, this one O, then TBDMS, and then this one OACCl, and now we can join that one, that compound in a equatorial manner, and then we will get over here is a what is that? See here, actually we will get this one, then we will get this type of the compound OBN, and then OBZ. Rest of the thing is this one OBN, and this is joined over there. Now here we can write OBZ, and here again as a OBZ, and here that remains as a SET, right? Yes, ET, that remains. So what do you, this is again as a thioglycoside, is remains as it is. So this is the one of the, and it is act as an promoter, and we are getting near about 90% yield. It is a very high yield. So how suitably they can get as this type of the derivative. So that is a thing which we have seen over here. And another example, now this thioglycoside, now combining these two, this is act as an donor, that is a it is a glycoside bromide, act as an donor, and thioglycoside here act as an acceptor. They couple together, they form as a O-glycosidic bond, that is a thioglycoside, in presence of AgOTF. It is act as an promoter. We got as this compound, and this compound further get converted into this one. Let's see here, we can write the same structure as it is combined with another this one. Now this structure again I am trying to, now this compound nucleophile attacking from the backside, equatorial becomes as axial. That the changes we are going to made over here. So let's see here how we can get this one. So let's try to draw the structure over here. This is a N3 compound structure we are getting, and rest of the thing, this one O, they are remains here. pH we can write, and this here O, other part TBDMS we can write as it is, this converted into, and this part remains as it is here. So we can show here this one, we can show as it is. So this is a SET thioglycoside, OBZ remains as it is. Here also at equatorial position OBZ, and but at this position OBN. So that is the compound. What we converted suitably, that sodium azide is added over there and we got as a N3 means azide group, that is act as a nucleophile, so it is attacking from backside, so that equatorial now it becomes as axial. That's the one of the basic concept you should remember over there. And now this can be treated with this reagent, whatever starting compound act as a donor that you can take. Once it is also as a thioglycoside, it is act as an acceptor now once again, and you couple with this, or you can take down this reaction as it is over here. So let me draw that structure once again. In this bromide group which is present at then here OACCl now is a O, this group as it is TBDMSO, this one, and now this is remains as a here pH, right? And now this and this combined together. After combining together in present promoter, again once promoter is used as a AgOTF once again, and this is act as an donor and this is act as an acceptor. That is the concept I am trying to explain over there. It is acting as an acceptor, means thioglycoside. This is nothing but as a this is a thioglycosides. This is also as a thioglycoside. This is also as a thioglycoside. They all are the derivative. When they combine together, the resulting compound will be formed over here. So what the compound we are going to get over here. Now here one more thing, remember, here we are suitably removing this group by the hydroxide, because this is going to combine with this one, with that halide, it donor, and finally the structure which we are going to get is this one, the compound which we are going to get. I am going to represent this compound over here once again, that is a S-E-T, then other thing O, then O remains here is a pH, and now at this side this group remains as it is TBDMS, that is a compound remain, and here what is the group OBN, which is a group, that is the derivatives we got over there. And in this way we have seen thioglycoside, how it can act as an acceptor, that we have discussed over here. Now the next point we are going to discuss over here is a thioglycoside as both donor and the acceptor, how it can play both the role together. Let us see that one. Thioglycoside, next point of discussion is this one. Let us discuss that point over here. What will be that one? Let us see here. Now is what is that point? Thioglycoside as both a donor and acceptor. Thioglycosides as both donors and acceptors Thioglycosides as both donors and the acceptors. So first of all, let us discuss about how it can act as a donor as well as it can act as an acceptor. At the beginning lectures, in our previous lecture we have discussed separately how thioglycoside can act as an donor, and in the rest of the lecture we have discussed how thioglycoside can act as an acceptor with the suitable example, and now we are discussing the thioglycoside, how it can act as both donor as well as acceptor. So that is the point we are discussing. With the help of example we are going to discuss this one. The protecting group pattern is known to have a large influence on the reactivity of the donor and of the acceptor, and this has been recognized for a long time but only been possible to utilize effectively in synthetic schemes with the event of stable donor, which has allowed the formation of donor with almost any type of protecting groups and patterns. And this reactivity difference can be utilized to permit orthogonal glycosylation between thioglyconide donors, that is reactive alkyl protecting groups, and acceptor in reactive, that is in reactive acyl protecting groups, exploiting less reactive promoters which only react with activated thioglycosides, and which is shown in the following scheme. Let us see that how thioglycoside act as an donor as well as another thioglycoside which can be act as an acceptor. Let us see the example over here. Now I am representing here the structure. Now let's see over here, that is a thioglycoside M.Sc.II, and then other hydroxyl groups are get protected with O benzyl group, OBN, here also OBN, and here also OBN, right? This is one of the thioglycoside. This is also as a thioglycoside. This is a thioglycoside. It is act as a donor. Let us consider over here. Another structure I am going to write over here, that is a BZ, and now here another structure I am trying to draw here. Here is a S.E.T, right? S.E.T, and now at one position here, primary alcohol, which is I am keeping here as a free OBZ benzyl group over here. Here is OBZ benzyl group, OBZ benzyl group. Here is a benzyl group, and this one is a benzoyl group. Now, and it will be a free, right? And this thioglycoside, this is also as a thioglycoside. This thioglycoside, it is also as a thioglycoside. It is also as a thioglycoside. It is act as an donor. It is act as an acceptor. Now, remember, this is a very important concept you remember here. It is act as a donor, it is act as a acceptor. Both are the thioglycosides, no doubt about it. And this, all the hydroxyl groups are protected, but here we are keeping as a primary hydroxyl group as a open over there, so that the coupling will occur between this thiol group and this one, and after reacting, and this here IDCP This is a reagent used over here, IDPC. And what is the another CH2 twice, that is a dichloromethane in presence of ether, Et twice O, and the compound which they have got is near about as a 84% of the product they have got over there. And now after coupling this, what is the product they are going to get over here, this coupled. So this you write as it is, but here remember that is a SN2 type of the reaction takes place, and that attacking from the alpha side. That is the thing you have to remember. Here we can draw the structure, first compound as it is, whatever compound OBN you can write as it is. Here also as a OBN which is lying at equatorial position. Here benzyl group which is present, protected hydroxyl group, and now here also OBN. But here now when this attacking, that becomes at an axial position, and you can show this one. So here you can draw the structure like this, and here remaining thing, here is a O, not O, that is the ST, and here whatever OBZ, here at equatorial position OBZ, and here OBZ, that are the compound, and this is the derivative we got, that is a thioglycoside derivative. This is also as a, because ACT at anomeric carbon atom, and therefore it is also as a thioglycoside derivative. This one derivative, this also as a thioglycoside, this is also as a thioglycoside, and we are getting as a thioglycoside. But here the main focus is these two words, donor and the acceptor. How one can act as an donor, how another can act as an acceptor, that we have discussed over here. So this is the point which we have discussed here. And now the next, the higher stability of phenyl thioglycosides as compared to ethyl thioglycoside with IDCP as a promoter has been shown, and this reactivity difference have been further proved by glycosylation with p-paratolyl thioglycoside donor and thioethyl acceptor using NIS in presence of TFOH, trifluorohydroxy, as an promoter, that is represent over here. So let's see what is that also. Here let's see that is also here how it can be act as an one can act as a donor and one can act as an acceptor. Let's see once again this structure. Let us draw over here this one. This is a structure here, SET, that is a thioglycoside, and all other groups are protected with benzyl group OBN. Here OBN, here you can write OBN and plus, and now we can draw another structure that is also as a benzyl, but here I am showing another structure. Here sulfur, then there is a paratoluene type of the compound, and now here OBN. Again these hydroxyl group are free for act as an acceptor over here, and here is a OBN. Here we can write OBN, and now these two compound, one act as a, this is a thioglycoside, right? This is a thioglycoside, glycosides. It is act as a donor, remember, because we are, and this is also as a thioglycoside general name, and it is act as an acceptor, right? It is act as one act as a donor, another act as an acceptor, and the compound that NIS, as I already told you that TFOH, NIS means N-iodosuccinamide, so that is a compound, and this will be treated with this one CH2 Cl2 dichloromethane, and how much solvent? The 92% of the product which we are getting over here. And after that, let us see how the couplings occur over here. I think this one, let me make the correction over here, so that is not there. So here, remember, here is a hydroxyl group which is at equatorial position, but one here is a acetyl group, OAC group is. So please make the correction over here. So after one is act as an donor, one act as an acceptor. Now the combination, how it is going to attach at the alpha side, right? This is a beta side, so it is going to, and the rest of the thing remains as it is. So I can draw the structure like this. Here OBN, then here OBN, here also as a OBN, the next one the OBN, here the oxygen atom, then we can draw here this one, this is the compound we can draw, and here this one is a, it remains as it is, we can show as it is, then OBN, sorry, something is not connected like this, so that should be different one. Let me show that one, that is a different linkage. So look at as a carefully I am showing over here. So this is a structure, right? This you can draw as it is, whatever it may be. So here OBN benzene, and here also OBN, and now here OBN, and here also OBN, and after that what is that? This group. So here let me write that group here, and here at this position, so we can represent their axial position, this one, and now this will be the structure we can draw here. This is a structure, and this yes, and now is a correct one. This is a structure, and here what is that? OBN, and here OAC, and here OBN. That is a structure which is and that is nothing but as a thioglycoside. It is a thioglycoside derivative. This is act as an donor, it is act as an acceptor, and we got the what we can call it as a this thioglycoside as an derivative. Now is a let us talk little bit about the application of that thioglycoside, and whatever we have seen, that is nothing but as application. Whatever scheme we have learned, that is nothing but as application. So still the stability of thioglycoside in combination with their easy activation make them highly suitable as donor in most glycosylation strategies and technologies, for example in block synthesis, as well as in technique where the donor is manipulated before glycosylation and in solid phase synthesis. I think these are the some of the application of this thioglycoside, and with this I think this much is enough as far as the exam point of view is concerned for the how the thioglycoside, what is the actually thioglycoside, how it can act as a acceptor as well as donor. With the suitable example we have learned these points in detail. So next, glycosylation method, use of phosphates, that is the next time we are going to discuss glycosylation method, use of phosphate. That is another similar to as whatever we have seen so far is glycoside halide, then trichloroacetaminates, then glycal derivatives and thioglycoside. Now the next point we are going to discuss about the phosphates, that is a glycosylation method, that is a use of phosphates. Glycosylation means how the glycosidic bond formation takes place. With the help of the some suitable example we are going to learn this one. I think with this let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.